Hey, Gary Parker here. We're going to take a look at week 2 of elementary algebra at Vermont Community College. So, share my desktop. Here we go. So, here we are in the Canvas course. I added a new thing at the top here called quizzes. Later today, the first quiz will appear. Quizzes are going to be written on paper, and then you'll submit a scan of that quiz to me, or you can take a picture of it with your phone and send me that picture. If you have any trouble doing that, let me know. I'll help you figure it out. So, bonus survey. I'm teaching another class in statistics this term, and I need to collect data about students. So, this is, I don't collect who you are. I just want to know a little bit about you. So if you could please fill this out, it'll help my other students out immensely, and you'll get a bonus for doing it. So it'll help with your grade in general, and it'll help other students out. So win-win. Other things to keep in mind: the textbook is something you should read, and you can get it from the BMCC bookstore if you like a print copy. It's pretty inexpensive. I use the web book. I think it's excellent, so that's right here. We're going to take a look at Chapter 2 in just a moment. In particular, we're going to start off with Section 2.5. So most days I look at the web book when I need to look something up in the book for examples. Other times I downloaded the PDF version, and there's a link to that in the course also. And so sometimes I'll come to the PDF version of it. For example, I have a copy of the PDF on my tablet and my phone, and I can just jump to Section 2.5. There we go. And on my computer, I can say, hey, make it wider. Bang, there we go. And so I can see similar examples. So everything you see in the web book is also in the PDF. All right. So, and again, both views are good. Generally, if you have web access all the time, the web book's great. If you occasionally don't have internet access, then grab that PDF, put it on your favorite device. You can grab that here. All right, so that can go away for now. Just other reminders. Canvas has a calendar built into it, and the Canvas calendar is both great and bad. What do you mean great and bad? Well, what I mean is it shows you when things are due. Now, in this course, I have everything due at the end of the week. So if you wait to the end of the week on Saturday to try and do all this, it's pretty unlikely you're going to get it done. All in one day ain't going to happen. Other thing is you're cramming and you're not going to learn it as well. So you need to do a little bit every day. So that's why we have that daily schedule that I asked you to print out and hang on your refrigerator or someplace prominent. So daily calendar, print this and hang it somewhere prominent. So as of Monday, you should be finishing up Section 2.5, and Tuesday starting and finishing 2.6. So here we've got about a section a day. Then you're going to review in order to take the exam on Monday, and I'll talk about the exam at the end of this video. Other things about this course. If you just look at the to-do stuff, you're going to miss out on important information in between. When you're done with a week, like week 1, you can minimize it, move on to the next week. So every week you should check out the textbook. I have a link to the web book there. There's videos that relate to like me teaching that day's lecture if it was a face-to-face class. So there's about an hour of videos in there that you can check out. And then there's the homework. In a regular face-to-face math class that meets 5 credits, 5 hours a week, I would expect you to spend at least 2 hours outside of class for every hour we spend in class together. So that means since this is an online class, you should be spending about 15 hours a week total on this class if you want to do well. If you want to do well, please do that. All right, next, let's do some math. So the theme from last week was warming up with arithmetic and then solving equations, and we're going to continue that theme this week with solving equations. Now here I say solving linear equations. Ooh, my pen's going a little nuts there. Sorry about that. This is what we call a linear equation because I have a number times a variable plus or minus some other number. So situations like that are called linear. If you ever have two variables multiplied together, or a variable squared, or a variable divided by a variable, it's no longer what we call linear. We'll get into that in a couple of chapters. For now, it's a linear equation. To solve something like this, we reverse the order of operations. If I knew what x was, I would multiply by 3 and then add 5. Since I don't know what x is, I want to reverse the order and the operation. So I would want to, instead of multiply first then add, I want to subtract and then divide. And that order does make solving the problem easier. So I'm going to switch colors here. And so I think I should subtract 5 first. And I have to do that on each side to keep things balanced. So plus 5 minus 5 is 0. 0 plus 3x is still 3x. On the other side, I have 7 take away 5, which is 2. So then I can move on to the next step here, which is to break this multiplication by doing a division. So I'm going to divide by 3 because I want to get x alone. I have to do that on both sides to keep things balanced. So 3 divided by 3 is 1. 1 times x is x. So here I get x equals 2/3. Anytime you solve an equation, it is an educated guess. I think this is the answer. I should plug it in to check. And on the quiz that you're going to get this week, I'm going to ask you to solve and check. So the check would look like this. 3 times 2/3 plus 5 supposed to question mark equal 7. And then basically I do arithmetic and hope. So 3 times 2/3. So fraction 3 over 1 times 2 over 3. When you multiply fractions, you can cancel ahead of time. So 3 goes into 3 once each. So here I get 2 times 1 over 1 times 1, which is just 2. 2 plus 5 is 7, which is what is on the other side, and they match. So that means it does check out. I did find the right equation. Now, what if you didn't follow the steps like I did? 3x plus 5 equals 7. And you said, well, I'm just going to divide first because I want to get rid of that 3 right away. Well, when you do that, you're trying to balance this equation right here. So you would have to divide this side by 3 and that side by 3. Everything has to be divided by 3 here to keep things in balance. What that means is both the 3x is divided by 3 and that 5 is divided by 3. So now I've just made my life a bit more complicated. So check that second step out compared to this one right here, right? Way easier. Solving equations is mostly about reversing the order of operations, okay? So that can be helpful tonight. So feel free to continue this to see it gets the same answer. I'm going to skip along here. So next problem. So this is a problem similar to what you would have seen in the last section 2.4. There's problems like it in 2.5 also. Here I have fractions and whole numbers, no big deal. To solve this right here, I would choose to reverse the order of operations on x. Instead of multiplying first, I'm going to get rid of the plus 32 by subtracting 32. And I can do that on both sides. 32 minus 32 is 0. 0 plus 9/5 x is still 9/5 x. On the other side, I have to consider what is 72 minus 32. So let's see, 72 minus 30 would be 40. Take away another 2, I get 38. Now, a couple of ways to look at the next part here. Either I can break this multiplication by dividing by 9/5, or I could multiply by the reciprocal. I'm going to go for multiplying by the reciprocal. So I'm going to multiply by 5/9 on this side. I'm going to multiply by 5/9 on this side. So the whole point here is this stuff all cancels. 5 divided by 5 is a 1. 9 divided by 9 is a 1. So altogether what's left on that side is 1x. The other side, I've got a little work to do. So let's see, I can do that as 38 over 1. And 9 does not go into 38. So there's not too much I can do there except multiply 38 times 5. And I'd encourage you to resist using a calculator as much as possible and only whip it out sometimes. So I can do this by hand. It's 38 times 5. 8 times 5 is 40. 3 times 5 is 15, plus 4 is 19. So I get 190 over 9. This is a great answer. The computer will love it. It doesn't reduce because 9 and 190 have no common factors. I know they have no common factors because 9 didn't go into 38 over here. Now, some people like mixed numbers. So if I was going to express them into another human, a mixed number would be great. Like I wouldn't say, hey, I live 199 miles away from this particular location. I would take the 9 into the 190. So mixed numbers are great for communication, but computers struggle with them, and they're not good for calculations. So this would be my answer right here, not a mixed number. All right, and again, we can check that by plugging it into the original and see if it worked out. I'll leave that up to you. Now here, I'm going to skip my analysis of this problem here and just talk about the problem and then how I'm going to solve it. So Netflix back in 2011 made headlines when it separated the streaming service from the DVD service. So I used to have Netflix, and back in 2010, for example, I paid $7 a month and I could stream all the movies, 2 DVDs a month, which was pretty awesome. And now some of you are younger, you may not even use DVDs anymore, but you might remember from you were a kid. Well, it turned out that in the time frame before 2011, Netflix noticed that the DVD sales were dropping each year, and the amount of streaming people were doing was increasing each year. And other groups, in particular a group called Instat, did some analysis on this, and they made a prediction about how they thought this was going to go in the years from 2009 to 2014. So here I kind of summarize that information, and then I knock it down to an equation. So it's the equation that I'm interested in. So I'm going to jump to the next page here. So this is the equation related to DVD sales. DVD sales are dropping over time. T is time. Streaming sales are increasing over time. DVD sales started at $8.73 billion. Streaming sales started at $2.3 billion. What I want to know is, when are streaming sales and DVD sales going to match up roughly, and when will streaming be ahead of DVD sales? And so solving this equation will help me find their intersection, where those two things meet. Okay? So the decline of DVD, Blu-ray sales, and the rise of streaming sales. So I'm going to go solve an equation like this. And it's not much different than solving the equations we already did. There's just about one extra step. Now, instructions here would be something like solve for t. That means I have to get t alone on one side. Problem at the moment is I have t's on both sides here. So what I'm going to do is I'm going to take this 1.216 and bring it to the other side. It's connected by a plus. It is positive, so I'm going to subtract 1.26 times t. Oops. From both sides, and I'm going to line up my like terms. Again. So balancing the equation and doing the same thing on each side. 1.26 t's minus 1.26 t's is a net result of nothing. That zeroes out, leaving me just a 2.3 on the right side. On the other side, the 8.73 is just chilling out, waiting to do something. And now I have to bring these guys together. So 200ths and 600ths is 800ths. The t is still chilling out there. Notice I put a little hook on the bottom of my t, so I don't ever confuse it with a plus. 9, 10, 11, carry the 1. 1 and 1 is 2. So I get negative 2.18 times t. Now this looks kind of like the equation I had before. I said there's just kind of one extra step here. The 8.73 needs to move to the right side. So I'm going to subtract 8.73. From that side, subtract 8.73 from this side. Now this may be a place you want to whip out your calculator, and my advice to you is try to resist. This isn't too bad. Oops. So something to consider here. Oh, those are reversed, so I need to do that off to the side. So I'm going to rewrite that as 8.73 minus 2.30. Since I switched the numbers to do subtraction correctly, I need to make a note that the answer is going to be negative here at the end. Right? I have a smaller number minus a larger number further from 0. 3 minus 0 is 3, 7 minus 3 is 4, 8 minus 2 is 6, oops. And that's going to be a negative 6.43 here. Sorry, my pen's freaking out. It's a new pen. Get used to it still. On the other side, this part zeroed out, so I have a negative 2.18 t. Come on, pen. Work with me here. So that t is connected by multiplication, right? No symbol in algebra means multiplication. So to break that multiplication, I'm going to have to do a division. So I am going to divide by negative 2.18. Always be conscious of your signs. Divide by negative 2.18. All right, now here is a place where I really don't feel like doing long division. This subtraction wasn't too bad. This addition wasn't too bad, but that's a pain in the butt. Note, negative divided by a negative is a positive, so I'm going to emphasize that there. Otherwise, I think I'm ready for a calculator. So 6.43 divided by 2.18. Read that again. So 6.3 divided by 2.18. I think I got those numbers right. 6.43 divided by 2.18 is about 2.95-ish, rounded. So there's my whiteboard. Undo that craziness. All right, so the answer again was 2.95-ish. And in the problems you get online, it'll sometimes say where to round. If it doesn't, usually 3 or 4 decimal places is good. So here I'm just going to go with that 2.95. All right, so I think here that t is going to be equal to positive 2.95. Wow. Now to check that, I would want to plug that number into each of these and see if they match. So let's see if I can do that. Split my screen so I can see the numbers. So I'm thinking the answer is about 2.95. So in my Google calculator here, I'm just going to try and type this out. So clear that. I want to know, plugging back into the original black left side there, if I take negative 0.92 and multiply that by what I think t is, 2.95, and then I add on to that 8.73, what do I get? Google says I get about 6.016. I'm just going to make a note over here and help me out. That, oh, come on, pen, next to bay. On the left side, I got, come on, you can do this now. I got about 6.016. All right, now since I rounded the 2.95, I'm not going to get exactly the same number on the other side, but I should be pretty close. 1.26 times 2.95 plus 2.3 should be about the same answer. Pretty close, 6.017. So rounding error threw me off a little bit, but not too bad. So over here, I got, my pen's crazy, 6.017. I'll have to play with the settings. So since this is rounded, right, it's approximate, these are approximately close, so that means the solution I found does work. So this is about one of the harder problems you'll see in section 2.6. All right, let's move along. Here's an easier version. So again, we have variables on both sides, and the general rule for solving something like this is make sure each side is cleaned up as much as possible. So 2x and 7 are not like terms, I can't clean up that addition. 5x and 3 are not like terms, so I can't clean up that subtraction. So now it's time to move things back and forth. And you can take whatever you want to the left and whatever you want to the right. Usually people take the variable, come on, pen, to the left and the regular numbers to the right. So I'm going to start that way. So I'm going to take this 2x, subtract it. And I'm subtracting it because it's connected by addition and it's positive. 2x minus 2x is 0. So I want it to go away. So I have to subtract 2x on that side. 5x minus 2x's is 3x's. Minus 3 equals 2x minus 2x is 0 plus 7 is 7. Now I'm ready to get rid of this negative 3. It's like the problems in 2.4. So switch color. So this is a minus 3. That means I want to do a plus 3. In algebra, minusing a number is the same as adding the opposite. So here I have a negative 3 plus a positive 3. That's definitely 0. So I'm going to add 3 to this side to compensate, keep things balanced. That gives me a 10. So on the right side, I have 10. And on the left side, I have 3x. Next thing, break that multiplication by dividing. And so I think that x is 10/3. Now, many of you may be wanting to whip out your calculator right now. And if you did, what you find is that 3 goes into 10 3 times with 1 out of 3 remaining, which comes out as a 0.33333, and that goes on forever. This is a problem, that infinite decimal right there. So we're going to say that our best answer is this one right here, not that one right there. So unless the problem says round to 2, 3, 4 decimal places, then you want to keep this a fraction like I have it here. So I think the answer is 10/3. So to check it, I would have to plug 10/3 into the left, plug 10/3 into the right, and hope that they match. All right, let's try another problem. In section 2.7, you're going to take a look at ratio and proportion. So a ratio is the quotient of two numbers. So here I have 21 miles, 2 hours. So let's say I went for a mountain bike ride the other day. I rode 21 miles. It took me 2 hours to do it. Okay? Now, if I clean this up by taking 2 into 21, then I would see that 2 goes into 21 10.5 times. So then I get what's called a unit rate. So this would be miles per hour. What does per mean? Per means divide. Miles divided by hours. Okay, and this red version is called a unit rate. Why is it a unit rate? Because since I have no denominator, you could say I'm dividing by 1. So I could also say that's 10.5 miles divided by 1 hour. So just carrying out the division that the ratio gives you what's called a unit rate. Now, a proportion, on the other hand, is when you have a fraction equal to another fraction. So here, what I'm trying to do, for example, would be to say, recently I averaged, I was supposed to be 21 there, not a 22. Sucker up. Recently I averaged 21 miles every 2 hours. How far will I go if I bike for 3 hours? So in this case, my numerators represent measurements in miles, and my denominators represent measurements in hours. So I'm trying to find out how many miles can I ride in 3 hours. The standard protocol procedure or algorithm for solving a proportion is to cross multiply. So what we do is we take that 2 and multiply it by the x. We take the 3 and multiply it by the 21. That gives me a new equation that looks like this. 21 times 3 would be 63 equals 2 times x, which is usually called 2x. So there's cross multiply, and then the next step would be to divide. So I would want to divide by that 2 right there. And so the number of miles is going to be whatever 63 divided by 2 is. So let's see, 2 goes into 6 3 times, 2 goes into 3 once, with 1 left over. 1 out of 2 is a half, 4.5. So here I would find that I can go 31.5 miles, which would be another 10.5 miles on top of the 21 miles. So that's one way to solve a proportion. And you'll do a bunch of that kind of stuff in section 2.7. Section 2.8, the last section of this chapter, is about manipulating formulas. So here's a classic formula for converting Celsius to Fahrenheit. Now, suppose we wanted to convert Fahrenheit to Celsius. So somebody gave me a Fahrenheit temperature, like 98.6. I want to know what it is in Celsius. So what I want to do is I want to get the C by itself. I want to know Celsius instead of Fahrenheit. So we're just going to leave that F there and we're going to proceed like we did before. So the goal in this particular situation for this formula is we are going to try and solve for C. Just like before, I want to get rid of the 32 first because it's added. So I'm going to subtract 32. Now the problem on the right side is before I had a number minus 32. Here I just have a letter minus 32. So the best I can say is at this point in time, I just have whatever Fahrenheit is minus 32. I can't clean that up. But now I'm going to write it out horizontally instead of vertically. 32 minus 32 is gone, so I just have that 9/5 C on the other side. Two ways to go from here. I could divide by 9/5, or I could multiply by the reciprocal. I'm going to choose to multiply by the reciprocal. Reciprocal is 5/9. Since the other side is complicated, I have to put it in parentheses and write it like this. And it doesn't matter whether you multiply it on the left side or the right side, because you can multiply in any order you want. So on this side, the 5's cancel and the 9's cancel, and the only thing left is the C. On the other side, this time I'm going to write the 5/9 first, and then multiply by F minus 32 in parentheses. And the order of operations is important here. First, you would subtract 32 from the Fahrenheit temperature, and then you would multiply by 9/5. So I'm just going to do a little check to see if this works out okay. So, for example, consider the Fahrenheit temperature 98.6, which is what we believe average human body temperature is. If I plug that into my formula, I'm going to get 5/9 times parentheses 98.6 minus 32. Here I'm going to whip out my calculator to do that and see what Celsius is. And then we'll plug in the other formula, see if it works out. So Google Calculator, clear. And we want to take 5 divided by 9, multiply that by parentheses. 98.6 minus 32. All right, so if you are an Android user, your phone is a calculator just like this web-based one, equals, I get 37 according to Google. So back here, I get Celsius temperature is 37. Now the original formula I started with said to calculate Fahrenheit, given Celsius, you would take 9/5 times the Celsius temperature and then add 32. I think the Celsius temperature is 37, so let's reverse it and see what I get. What happens if I take 9/5 times 37 plus 32? Hopefully I'll get the 98.6 back if my work on the previous page is correct. Here, 9/5 times, and since it's just one number, the parentheses are optional. So I'm just going to type 37, and I'm going to add 2, and Google says 98.6. So it did work out. All right, so that is an overview of the week 2 material. So just a couple other things. This finishes up week 2 once we get to 2.8. There's an optional practice test for chapter 2 and a required practice test for chapter 1. So you got to go and do that right there. So this is just like a homework assignment, but there's a few more questions than you normally see. There's a printable version here if you want to check that out too. So you can print that out, and then the answers are at the very end. So you could give it a try and then check your answers when you're done. The real test is going to be like the combination of the two of these. So what's going to happen is you're going to go to the testing center, They'll enter a password to log you into the real test. They'll also give you a paper copy of the test, which will look something like this right here. You work everything out on paper. After you work it on paper, you're going to go to the online version and type in your answers. So you get some feedback from typing in your answers online, and then I'll review your written work to double check your grade. All right? But take care, do good math. I'll catch you in the future.